Welcome to the Mechanical Engineer. In this video, I am going to show you how to draw the free body diagram for strings and rollers. So first of all, what is free body diagram means? A free body diagram is a visual representation of forces acting on an object in a given situation. So under equilibrium conditions, so we know what is equilibrium condition. The horizontal forces is equal to 0. The vertical forces is also equal to 0, so that there will be no resultant acting in the system. In that condition, the system is said to be equilibrium. So in the equilibrium state of position, there will be forces acting, but the summation of forces will be 0. So with the help of free body diagram, we are going to represent the magnitude and direction of forces acting in the system. So let us start with a simple example. So here, this box is placed on a table. So to draw the free body diagram, actually we have to isolate the object. So I'm going to isolate this box and I'm going to draw the free body diagram. So let me consider I have a point A here. So the weight of the box will be acting in the downward direction. Let us say it is WA. So when there is no contact between the box and the table, to keep the system in an equilibrium position, we have to provide an opposite reaction force, RA. So the weight of the box is acting in the downward direction, and as there is a contact between the box and the table in real, there will be a reaction force that will be acting with the same magnitude and opposite direction, RA, to keep the system in a equilibrium position. Now, the magnitude of both WA and RA will be equal. That is why the system is said to be equilibrium condition. So here, this is the diagram that shows all the forces with its magnitude and direction that is acting on the box. So this diagram is called as the free body diagram. Okay, so the FBD. Now let us see how to draw the free body diagram for simple strings and rollers. So first I have considered a string system. So actually it has 1, 2 and 3 strings, and it is attached at the top of the floor. So let me name the points. So let us name this as A, B, C and D. So to do the further calculations, first we have to draw the free body diagram. So I'm going to draw the free body diagram about the center point A, because in that point only all the forces will be acting. So here we have a weight W, it is acting in the downward direction. So I'm marking a weight W, weight D, that is acting in the downward direction. Now here AB is a string. So about strings, in strings we can only apply tensile load because we cannot compress the string. So wherever you have a string, you can directly apply a tensile load. So from A, there will be a tensile force acting in that spring, and that force is acting from A to B. So it is TAB. So similarly, in between A and C, we have another string. So a tension TAC will be acting like this. So this is the free body diagram of this force system. Now moving towards the next one. So here we have A, B, C and D, and at B and C we have some weights W. Okay, so here I am going to focus on 2 points, that is point B and point C, because there only we have 3 strings. So let me start with point B. So I'm going to start with point B. So in point B we have weight W acting in the downward direction. Then in between B and C, we have a string. So a tensile force will be acting, that is a tension will be acting, and it is called as T. From B to C it is acting, so it is TBC. Then between B and A, we have another string. So it is TB to A. Now coming to the point C, a weight is acting in the downward direction, W, and we have a string between C and D. So it is T. From C to D it is acting, so TCD. Next, in between C and B, we have TCB. Now, this TBC is equal to TCB because both are same strings. Now, moving to the rollers. So here, the roller is fixed on the wall with the help of a string. So let me name the points. I'm going to name this as A, B and C. Okay, so for the point B, I'm going to draw the free body diagram. So this roller has some weight. So that weight will be acting in the downward direction. So it is W, B, and we have a string, and that string tension will be acting like this. So T, from B to A it is acting. So far we have drawn the weight and the tension. Now we have a contact between this roller B and the wall at point C. So at that contact, there will be a reaction force will be acting, and that reaction force will be acting in between B, C to B towards the object. Okay, so from C to B, the reaction force will be acting. It is R, C. Okay, so these are the three forces acting on this roller. Now coming to the next roller, so here the surface is inclined. So I'm going to mark the points A, B and C. So starting with the weight, a weight of WB is acting in the downward direction, and we have a string between B and A, so it is TBA, and as we have a contact at point C, a reaction force will be acting, and the reaction force will be acting connecting the points C and B towards the object. So from C to B, it is acting. So you can identify that. So it should link the points C and B. And it is a reaction force. That is why it is acting towards the center of the object. Now this one. So this is almost the similar. We have point A, B. The first contact is C. And we have one more contact at the bottom. That is D. So usually the weight will be acting in the downward direction. W, B. And we have the tension from point B to A, so it is TBA, and we have a contact at C, so a reaction will be acting like this, or C, and we have one more reaction at the bottom, so one more reaction will be acting in the opposite direction, or D. So this reaction direction should connect the points D and B, and it is acting in the opposite direction as it is a reaction force. So totally there are 1, 2, 3, 4 forces are acting. Now coming to these two rollers, so I'm going to mark the center points. So I'm going to mark it as A, B. There is no string here. So let us mark the contact. Then we have C, D, E. Also we have a point F. So the F is the contact between the rollers A and B. So first consider roller A. The weight of the roller will be acting in the downward direction. So W, A it is acting. And we have no strings, so directly we can start with the reaction force. A reaction force RC is acting from point C to A. So this is RC, and you have one more point at the bottom, that is contact D. So it is acting in this direction, RD, and we have a contact between the rollers A and B. So here a force is applied from the roller B to A. So I am marking BA because the roller B is applying a force FBA to the center of the point A. Okay, so we have a weight, two reaction force and a force due to the next roller. Now coming to the point B, the weight B will be acting in the downward direction, and we have a reaction or E, and we have drawn FBA. So FBA, if FBA is acting in the downward direction, there will be opposite force that is resisting the motion. So it is FAB. Okay, so because if FBA is opposite to the FAB only, the system will be under equilibrium conditions. Okay, so this is actually almost like a reaction force. And here, this FBA is same as the FAB in magnitude, only the direction is changing. Now this one, so let us mark the centers. So A, B, then contacts, we have C, D, E and F. So first, considering roller A, the weight will be acting in the downward direction WA, and the reaction force RC is acting like this, and we have one more reaction RD as there is a contact at the bottom, and from the roller B, a force FBA is acting. Now coming to the roller B, the weight of the roller WB is acting in the downward direction, and there is a reaction force from point E as there is a contact, so it is RE, it is acting towards the object, and an opposite force an opposite force for FBA, that is FAB, is acting in the object towards the center point. So we know that FBA is same as FAB in magnitude, only the direction changes. So once you draw the free body diagram, then with the help of Lami's theorem or with the help of resolution of forces, we can identify the unknown forces in the system. Thank you.